Right, good morning, everybody. Yet another Wednesday webinar. This one particularly I've been looking forward to for a while, not least because it marks another version of our new embodied carbon calculator coming up, which reflects the latest kind of benchmarking and targets that have been set by a load of clever people in the industry. So the next, I would think this one's going to be a bit shorter. We'll maybe make this one half an hour. Depends on how many questions we get. Hopefully we'll get plenty of questions off the back of this one, but I won't be rambling on for 45, 50 minutes. I'm actually sharing this presentation with a colleague of mine, Jenny Wallace, who will actually show you the calculator, but I'll do a bit up front, just talking about the main points and just a tiny bit of background behind it. So without further ado, just a bit of etiquette as normal. Do try and keep your mics on mute. Do use the chat box. We'll answer any questions at the end to keep it nice and clean. So anything you think of whilst we're talking away, feel free to pose a question and we'll try and answer those for you at the end. And we are recording this webinar. All of our webinars end up on YouTube for the benefit of others who have to drop off or stumble across or want to find useful information on this kind of thing at a later date. So you are being recorded. As you guys will be well aware, we're trying to and successfully getting a large number of people on our Meshwork community. This is a free community where we're trying to encourage people who care about sustainable design to coalesce, discuss, learn from one another, invite others who might be interested, and really try and further the progress that we're all trying to make in our own little way. So you guys already signed up, and there's a good reason why we're keeping some exclusive content on there to try and encourage others to the platform as well. So as we normally encourage you to do, spend some time on there, do ask questions and share with your colleagues as well. There's plenty more to do, and we'll get there faster by sharing that information with each other. So a quick kind of 30 seconds on Mesh Energy. If you're new to these webinars, Mesh Energy are a independent and holistic energy consultancy. We're based in Farnham, Surrey. We do projects across the UK and Europe, and even some in the States we've been known to do. And fundamentally, we're here to partner with other people who are involved in sustainable design and use our experience, use our toolkit, use our, connect you with other partners to try and make your design as successful as possible. And we can get involved at any of the Reba design stages, ideally as early as possible, to try and bring the greatest level of success to your project. And as you've probably figured out, we're a big one for kind of educating and sharing what we know. So whilst we have our kind of the mainstay of the business is energy consultancy and sustainable design, we're doing increasingly more with education and, as I say, sharing what we know for the wider benefit of others. So to today's webinar, this is all off the back of a whole load of work that was done by LETI, the RIBA, Whole Life Carbon Network, and a load of other bodies and a load of other volunteers who is seriously impressive, the work that's going into furthering our understanding of embodied carbon, agreeing targets. I was only reading this morning the definition document there by the Whole Life Carbon Network about the definitions of net zero, the definitions of, what does carbon neutrality mean? It's all laid out in a really, really simple set of documents. And our embodied carbon calculator builds off the back of that thinking to bring some really, a really useful tool to you guys without having to go through reams and reams and reams of paper every day, and actually bringing this to bear on your live projects. And we've got a webinar that we did a couple of weeks ago on these various targets. So I'm not going to go over all of this, but the carbon calculator builds off of that hard work. And of course, we've got the Reba 2030 Climate Challenge, which we've talked about numerous times. And again, this has set revised targets for embodied carbon, which we're building into our calculator as well. Now, the big change recently is how we output or how we record and how we share with others in a kind of a meaningful, concise form, the embodied carbon in buildings that have been designed or built. And as you'll see, this is in my mind, a really sensible addition. It's in a familiar form. This banding system is very similar to EPCs that you get, and energy efficiency of appliances. So it's one we're all familiar with. And the carbon output table on the right-hand side allows you to kind of break down into the various chunks and carbon life cycle stages for various different bits of the building, whether it's superstructure, substructure, finishes, FF&E, renewable technology. And at first glance, that's a bit of a headache, but the whole point of our tool is to help you try and populate as much of that as possible. But it's the output of this and the sharing of this embodied carbon information, which will really, again, help try and accelerate learning from others as we share this more collaboratively and aren't afraid of other people looking at the work that we've done. So an overview of the calculator, as I say, Jenny is going to do showing you the actual kind of demo, but I'm just going to run through the kind of the salient points here so that Jen can focus on the actual calculator bit itself. The key features of the calculator, the main reason that we updated this was to take into consideration these outputs and these new targets. But for anybody who's used the calculator before, fundamentally, our calculator is based up on kind of building up the layers and the elements within key external element features like the roof, the walls, the floors, putting in windows and doors and things, a bit like you would construct a house. And the main reason that we do that is not only do you get almost an instantaneous idea of kind of U values for that element, but it just kind of makes sense to us, and we're using that calculator work to release another calculator very, very shortly to help with operational energy and various other things. So that's the way our calculator fundamentally works. You build up choosing a material, the thickness, the area over which it covers, and you build up those elements. And you put in the key building services. So you put in the fabric elements, you put in the building services. Are you having what heating system are you having? What, having any PV, having any cooling, those kinds of things. And then any other embodied life cycle elements that you know of or you want to put in there, you can now put in there. And you can also, we added in the last variant, be able to add in your own kind of bespoke material data. We have, I don't know, it's probably 30 different types of materials that you can put in there, but we've got a few slots where if you have a material that's not listed, you can put in your own material. And if you can dig out an EPD for that, then you can put that into the calculator as well. And as I say, the big output, the big addition here is these letter banding outputs and adjustment for the targets, and being able to report the carbon in an agreed fashion as well. And we've arranged those sheets such that when you do create that data, you can print out onto A4 pages and share that information as easily as possible. So that's in a very, very quick nutshell, that's what the calculator is about, and that's some of the additions. In the actual calculator yourself, you'll see this. We have a number of tabs. We've changed a few of the tabs in the calculator. You've got a kind of a read me first tab, which is just a kind of an overview of the calculator. We've got an assessments and targets tab, which remains. We've got some hints about operational energy targets that you need to meet for the U values, i.e. the thickness of the walls and type of insulation that you need to put in. We've got a new and expanded materials tab. We then have the calculator itself, and then, so the calculator is in blue, and the two outputs, the energy rating, or the carbon rating, sorry, and the carbon reporting are in green, so those are output ones. So in the assessments and targets tab, you'll see this. It's kind of similar to the one that we had before. What we've actually done is just reiterated exactly what we're capturing here. So what makes upfront carbon, which is the LETI targets, and what incorporates embodied carbon, which is what the Reba targets hang off, and just reinforces the RICS life cycle stages for materials. I guess the notable difference here is previously, whilst we were using LETI information to for stages A1 to A3, which is about processing. It's the kind of the product stage. It's the mining of the raw materials and transport and processing, and then extrapolating for these other life cycle stages. We've now dug into one-click LCA and given you all the data. So we're not making any assumptions or extrapolations. We're actually giving you the data through the product stage, construction stage, in use stages where possible, and end of life cycle stages that actually come from reliable, verified EPDs to try and refine the information that we're giving you there. This, the next one, which is the Reba 2030 operational energy guidance. This, the point of this tab is because whilst we're trying to reduce embodied carbon, as our building efficiency and operational targets get tighter, you can't just look at these things in isolation. We need to be aware of the improved U values that we need to get to, say if you were going for a Reba 2030 target, and you need to make sure you're putting enough material in the building to hit those nominal kind of U values so that you're not light. You think your embodied carbon's fine, and then when you actually come to figure out what U values you need, you found you've got to add a load more material to the walls to get the right U values. So we've broken this out into domestic buildings and offices and schools, which generally speaking have different operational energy targets, and they're fractionally different U values that go into the various elements. But also there's things like the heating and hot water systems, air tightness, ventilation, and a suggestion of kind of energy generation levels that you're going to need as well. So there's a slight change to that particular one. This is the carbon calculator tab. This hasn't massively changed, but there are some considerable changes. You'll be familiar that up in the top left-hand corner here, you input a load of data, and Jen will run you through this. So this is your main input, the name of the project, what type of building it is. We've got who the assessment's been done by. You can set targets, and it gives you a kind of live output of the targets and where the building's at. This section, although I've cut the page off here, is all where you're putting in your roof materials, floor materials, wall materials, windows and doors and things, and you scroll down there. That's nothing new. That's where you put in your layers. We've got a couple of little bits in there which Jen will run through, but nothing really changes there. The big addition that we've got to this is we've broken out for you. When you pick materials, it tells you what the different embodied carbon elements are per square meter of kind of GIA for the different life cycle stages. So we've given you that information, and obviously that comes from our material database. And then we have our graphical output here. So we've got the one at the top here with all the green horizontal bars. That's for the building as a whole, and that doesn't include sequestered carbon. So that's giving you an idea of the carbon for the various elements, but doesn't include sequestered carbon. So if you've got a lot of timber in the project, it's not taken into consideration the kind of saved or sequestered carbon. And these other elements with the multicolored kind of what they call tree map graphs, those show you for the roof or the walls or the floor, the carbon that is in there as a proportion of that element. So you can see where the big hitters are, you can see where there's a small amount of carbon. It gives you an idea of some of the things that you might want to change if you're outside of a target, or you're trying to keep your carbon as low as possible. And then we get onto the output pages. So I've split this into two. When you fill in that data on the other embodied carbon page, it automatically populates this carbon table. And then on the final page, you have the output for both upfront carbon, which doesn't include sequestration, and then embodied carbon, which is for all the life cycle stages and includes sequestered carbon. So that is a real kind of whistle-stop tour through the calculator and some of the new bits. What I would say before I kind of hand over to Jen here is, it's one thing coming out of this calculator, but I think it shouldn't be underestimated that we are keen to improve on this. We're keen to discuss it. We're keen to, have you guys tell us how we can improve it. And you know, and share our results. So as a result, we've set up a group which is the Embodied Carbon Calculator group. And so we want to see your questions there. We want to see your feedback there. We want to see results shared there. And hopefully this will give us a better kind of hangout place to talk about what's good, what's bad, what's ugly, and what can be improved around the calculator. So do check that group out, join that group, and hopefully we'll see you on there shortly. So Jen's going to do a demo for us. This final slide, I'll let Jen just kind of introduce the project that she's going to run through, and then we'll get Jen sharing her screen and off we go. So Jen, over to you.
Thanks. So hi everyone. I'm going to run through a project. This one in particular is a really great example of the embodied carbon tool because it's only at design stage 2. And so while we love getting involved really early, as architects, you can add an awful lot of value by having this information at your fingertips as the design development develops. So just a quick intro, it's a 4-bedroom family home. The client is really keen to reduce carbon and be just generally environmentally friendly. They're also keen, as a lot are, to have a certain kind of aesthetic with stone cladding. And a lot of the early conversations that I've had with the architect so far has been around whether those two are mutually exclusive or not. So we're going to delve into the numbers and do a little bit of an investigation on that. So let me share my screen. Should be able to see that now, fab. So first of all, we've got our standard input text in full kind of Blue Peter fashion. We'll be going through this. So 448. So most of this is just standard information around your project. You'll notice as you change the type of project and the target that you're going for, your targets here, your embodied carbon targets per meter squared of floor area, those change. So you can check in on those as you're building the property in the tool, just to see how you compare. We've got these two here, which obviously aren't showing anything yet, but as we input data, those will start to update. So let's go for the LETI A target. It's a residential property. This first little section here is all around any demolition or any facilitation works that are taking place. In this particular project, we know that they're demolishing an existing building, and so I've put a figure in for that. If you know that you've got toxic material or contaminated soil to be removed, you can put that in as a kilogram metric. There are some other options in here around specialist groundworks. These will be very specific to your project, so we've left the option there to put them in against the various life stages. So just dropping down a little bit, we've got the roof build up as the first element. You'll notice that these are split into sheet materials and non-sheet materials. So your sheet materials, those are being calculated to give you your U value, and those are everything that's across the whole span of the area. So typically your insulation, your roof tiles, and your non-sheet materials will be structural materials. As you get further along in the design, and you maybe have information from a structural engineer, you can pad this out. So this is a first pass. A couple of new features here. We can either say that the element is new or retained. So if you were, say, reusing some roof tiles, you could tell the system that you were retaining them from a previous project, and that would automatically fill in 0 under the A lifestyles over here. But we're going to be building those from new. And the other option you can select is around the element type. So if you don't select anything here, it's going to default to the roof. And similarly for walls, it will default to walls. But if we want to pick out certain items like finishing or the frame, when we're carbon reporting at the end, selecting them here will just enable you to have that additional bit of granularity. So I've selected my plaster as being a ceiling finish and the timber as being the frame. So there's only one roof on this, or one roof type on this property so far. 127. Important to put in the area against all elements. So not forgetting to put it against the timber size as well. Okay. So external walls. So here are my two external wall options. I've got my rendered external wall and then my stone clad external wall. When you're selecting your items here, so if you knew, for example, that you had a particular type of stone that you wanted to use, from a particular area, or you had a particular EPD for that precise material type, you can actually, as Doug was saying earlier, input that at the bottom here, and then that would appear at the very bottom. Let's go to the stone as that's the example. At the very bottom here, you can see insert your own material here comes up as an option. So I could put in stone 2, and that would appear just under there. I could put it in. I'm not going to. That was my tightness membrane. So the other thing to note is that the order of these materials as they appear in this list is actually from lowest embodied carbon to highest embodied carbon. So when you're searching through, that can help just to locate them on the list. So for the time being, I'm going to have all of my walls being rendered. Important here to note that your walls need to be your walls without your windows. So subtracting your windows areas from your wall areas, so you're not double counting them. So external walls, internal walls, this is just going to be plasterboard, cellulose insulation, and then again the timber. So internal walls, I've got my little list here. Internal walls at 189. 189. Oh, I've almost got 00. And I've pre-populated this. We've got some external doors that are going to be wood, double glazed with a wood or aluminium frame. So there's 7 meters squared of that. I know that I've got 17 internal doors, so that's the number of internal doors, and 30 meters squared of double glazing. Then had a go at the floor build-ups, just roughly making an estimate. So we haven't got full structural engineers details now, so we're putting in a punt. We're just trying to get close enough in this early stage. You'll notice that the areas for your floors are highlighted yellow. These are really key in driving the calculator. So it will be these floor areas that then bring the rest of the calculators to life. I'll just zoom out a bit here, and you can see that by putting in those floor areas, it's not coming.
I wondered, Jen, if it's one of those, I don't know if it's column Z, I don't know if you hid that or made that small, but it might be that that's causing the issue there.
Live webinars. Oh, so yeah, I mean, I just made it small, but it took it as being hidden. Oh, well, there we go. So, yeah, so putting in those floor areas in the yellow boxes, it brings the rest of it to life, because all of these columns R across to Z are all calculating are all calculating the rest of the figures based on the floor area. So as soon as you put those in, everything starts to open up, and we can start to see some proportionality coming in how the different elements are splitting across the whole building. So
I would just say there, actually, sorry, just to cut in, Jen, I would just,
yeah, sure.
if it works for some people, it might be worth starting with those bright yellow cells, because you know what the floor areas are. And then when you start putting in data, you'll immediately get graphical data from the start, rather than investing a load of time in putting stuff in and not getting feedback. So I personally sometimes just start with those bright yellow cells, because it is so critical that information goes in and the other numbers come off the back of that. But of course, it's entirely your preference. And a quick note there that I put in the chat box, these light yellow or bright yellow cells are the ones that you can input data into, whereas the blue are the output cells. And that's just a general thing to look for. So if it's yellow, you can chuck something in. If it's blue, you'll get an answer back out.
And we can see now that we've put those floor areas in, we're actually getting some feedback on how the property is performing against the LETI target and the Reba target, and it's doing quite well. So let's carry on. I'll just zoom in a little bit, save your eyes, and we'll come down. So we put in details around the doors, around the floor areas, and so then the next details to add are, we can add details around furniture, fixtures and fittings. Now, obviously, that is going to be very, very specific to your project and the taste of your client and the spec that you're including. So we've left the cells across here as yellow so that you can include your own details there. At this stage, we haven't specified any of that, so it's a little bit too early. What we do know is that it's likely there's going to be solar PV on the roof. We know that they're going to have a fairly small air source heat pump. They'll have a domestic hot water cylinder. They won't have cooling. Their preference is for underfloor heating. And given the air tightness targets that we're planning on, they'll need an MVHR system. So all of that's been included. There are a few more options on the bottom, all around the any works to existing buildings. So if you're having an extension, etc., or any external works, prefab works. For this building, not appropriate at this stage, but it allows you to add that detail if you have it for your project at a later point. So now we know.
Sorry, Jen, I just spotted there on your, where you've got your non-sheet materials, you've missed out in column H. There's some missing data on the distance between the elements. So if you scroll up, you'll see that some of those cells are empty. I think for the walls and stuff. If you scroll up, you should be able to see that. So there in the walls, there's no data.
Oh, I see what you're saying. Okay, let's go. Well spotted, thanks. Has that changed the results? No, we're still looking good. We're still looking good. So double check on the frame. So we can now whiz across to the ratings badge, and we can see we've got a nice little output here showing where we perform against the LETI target and the Reba target. This one here is including the sequestered carbon. Now, because we're looking at a timber frame build, obviously there's a lot of sequestered carbon in the timber. So that's why we're performing better when we look over the whole life of the project rather than just the upfront carbon. And then if we want to look in slightly more detail, we can see, I'll zoom in a bit, we can see how that all shakes out across all of the different areas. So you can see this was what I was alluding to earlier when we wanted, if we want to pick out specific details around the frame or around the external walls or the finishes, you can, this is in this in these drop downs here. So that's where that data is being picked up from. So still work without it, but you won't get that level of granularity. So let's have a little play then. Let's go back and see if we were to choose a stone wall or stone clad wall, would that change our results significantly? So I'll put that in there and put this to 0. So now we're saying that all of our walls are of this stone clad build up rather than the rendered build up. And we'll go back over to here. So actually it's not affecting it too badly. Not significantly at all. Now obviously that will depend upon exactly where you're sourcing your stone from. If it's local, it'll be even better. If it's coming from further afield, it'll be worse. But it certainly doesn't make this project. It doesn't give this project a poor embodied carbon score. The other thing we could do, let's say we were using stone from a recycled source, or recycling it from the previous project, we could say that was retained, and it would remove all of the assumptions in the A2, A5 band, and still include the end of life and replacement carbon. It just gives you that slightly better score up front. So the good thing about these output tabs is that they've been sized so that you can output them as a PDF. You can print from here to PDF. You can, if your particular machine or printer doesn't give it to you nicely on a single page, you can change it and say shrink to fit on one page, and that makes it nicely fit on one page. So that's really easily shareable with clients, and as an insert to a report, or a printout to take to a meeting if you're going to talk through it.
One of the other things I was going to add there, actually, Jen showed you the materials tab there with stuff that you could put in the bottom. I am aware that there's considerable amount of people using the iStruct tool. So what you could do here is actually put in, rather than a single material, the output from the iStruct tool would allow you to fill in boxes A1, A2, A3, A4, you know, B whatever, C whatever. And so you could put in there, I don't know, you know, whatever element you chose to, because the iStruct tool is pretty good, and put that in almost as a kind of a sub-assembly and select that under, you know, substructure or superstructure or whatever. And then it will factor that in. So there is a way of using the output of the iStruct tool for assemblies rather than individual materials. You've just got to call it the right thing.
So I mean, I'd like to open the floor for questions. If anyone has any questions following all that, it's a bit of a whiz through. You might want to have a little play, but if anyone's got any questions, happy to take them now.
Yeah, I was going to say, I was just reading Zach's question, actually. Sorry, I'll turn my video back on. Zach, do you just want to explain your question there? So Zach's asking about working on extensions.
Yeah, sorry.
Each field to get the result. Do you just want to explain? That might be easier, just talking through that one.
Sorry if it was unclear.
No, it's fine, it's fine.
No, I'm just thinking that, you know, one of the things we're trying to do at the minute is use small projects to develop, you know, ideas on retrofit and that kind of stuff.
Yeah.
If you're doing a new house or a new office, it's very clear. If you're doing a new extension, do you use the main body of this tool as an extension, as a separate thing, just to work it all out, or because you've got a bottom tab that says extensions but there's nothing on it, as if you would just basically almost put each figure in for each, you know, for the whole extension per square meter. If you click on,
you mean in these bottom 3 rows here that Jen's
typing? Yeah. Can you just add a whole load? Can you add all the stuff you've got above into each one of those headings?
You yeah. Well, essentially, you could calculate what that is, scribble down the numbers, and then fit into the, you know, work to existing buildings line there. So, you know, although there are a lot of cells here, this is simply what volume of materials we've got, and then it's adding up the values in these blue columns to give you your totals. So if you've got, if you wanted to, for example, work out for an entire extension what the embodied carbon was going to be in those different life cycle stages, you could do that. Make a note of that, or vice versa for the existing building, given that you were going to retain a lot of stuff. And you can put those numbers in, so old can meet new in that fashion. But it's probably worth us having a chat about that kind of offline, Zach, because it's a bit kind of funny, some of the things they've got at the bottom here. Prefab buildings. I mean, that's a big catch-all for one single line in. Yeah. And this whole thing could be used for a prefab building. I mean, if you were using PR and those other things. So it's probably worth discussing that offline, Zach. And if we can kind of make sense of that or make it easier for people doing work on existing buildings, then we'll try and do that. But
thanks.
It's probably not as tricky as you imagine.
No, I was thinking that you simply fill, if you ignore this section, you fill in the thing from above, and you still.
Yeah, you could do. Yeah, you could do. Yeah, that's entirely possible.
The answer would be correct. It just wouldn't appear in the right boxes on the reporting tool, but you still have the answer.
Yeah.
Okay.
Yeah.
Thanks.
Yeah. It's. I mean, what we were thinking of doing, hence why we'd added in kind of column C there, was allow you to break out into the individual buckets, those individual constructions. So we might do some more work around expanding that to allow you to calculate something and then throw it all in the work to existing buildings cells in another part of the calculator. Yeah, that's all. It's interesting to hear that, and as things evolve, we'll see what we can sensibly put in there without making it too unwieldy.
Thank you.
No worries. Any other questions from anybody else? I know it, for anybody who's used this calculator, it certainly, well, if you haven't used this calculator, it seems like there's a hell of a lot of stuff to put in. I promise you, this is the simplest way that we can think about doing this, and the best way to do it, other than once you put in your project information, is just line by line, just go through your constructions, figure out what you would likely be putting in your walls, look at the thicknesses, pick the nearest material to that. Remember, this is an early stage calculator, so although the embodied, the life cycle, carbon life cycle information is very accurate, the materials don't have to be the exact grade of stone or plywood or something. You're going to be in the right ballpark if you choose a generic plywood, even though there are lots and lots of different types of marine ply and basic ply and all kinds of other things. So yeah, just line by line, just go through your constructions, pick out what technologies you're likely to be putting in there, and see how you get on. But we're always keen for feedback. And once you've used this a few times, you'll be able to rattle through and you'll understand how it's working. But I'd say this calculator, the way that we've done this, leads very little to the imagination and very little to assumptions, which is what I believe is the smart thing to do, but also is a great springboard for some of the other tools that we're bringing out, particularly around operational energy at early stages, being able to predict that. So we'll be talking about that later. A couple of questions up here. Laura, if the project's a retrofit, do we need to take into account everything that is in there already? So there will be things that can be reused by the same project, reused by others, recycle and waste. So if it's a retrofit project, by rights, you should be building out the house or the offices or whatever it is, but you're going to be, rather than new materials, you're going to be putting reused materials in there. Because that, as I say, that knocks out everything to do with the production of that material, the transport of that material to site. So for an existing building, you're still going to have that replacement during the building's lifetime, and you're still going to have to deal with the end of life stages of that material. So if you had a house that was sat there and you were building an extension, you would design that house as is and put everything to retained. And then the new extension, you would be adding on, you know, the new wall, the new roof, whatever, and that would all be new. And that's, you're going to get a great embodied carbon score for the square meterage of the building. And that's why retrofitting buildings is strongly encouraged, because you're not creating all those materials from scratch. So you would have to build out the existing building as is in the calculator, and then add on under your different building types or your different element types, the new bits. I can appreciate that gets quite restrictive because we've only got kind of 2 or a couple of different element types that you can put in there. We have been asked previously, can we put in 3, 4 different element kind of construction types? Yes, we could do. Yes, it would get longer. And maybe with more people doing retrofit projects, that's what's needed. It's quite simple to do. So if we get enough requests for adding that in, we can add that in quite easily. And Lucy's asking, where do you find all the information for the materials? So this is, we run a license of one-click LCA as a practice, and we have delved into that, which is professional software, and it has all verified EPDs. It has thousands and thousands and thousands of EPDs from around the globe. So we've taken verified EPD figures for the different RICS life cycle stages, and that's what we've got in here. And that's what really matters. That's why there's very little left to chance or extrapolation in here. It's actually the data per cubic meter of stone or plywood or whatever it is. So that's where the data is coming from, professional software. And Yvonne's asking, what if you have more type 2 types of external walls? Can you add more types yourself? No, Yvonne, you can't. That's something you would have to put in there. So as I say, if that's a suggestion you want to make on the group, we'll do that. It doesn't take us long to change it, and if there's enough requests, we'll add that in there, and we'll make that 5.1. So it is where it is, and we may have to add that at a later date. Anybody else got any other questions? A reminder, I would strongly encourage you guys just to use this, use it, abuse it, share the results. The more you do this, the more familiar you'll get with it. Hopefully other people who have embodied carbon calculators will come out with their versions of it, which are just as user friendly. But yeah, for the moment, we'd love to see you guys using it and letting us know what you think. Next week's webinar, just whilst we wait for any last few questions, is, and I'm just trying to remind myself what the next week's webinar is, just bear with me, is
And Hendra's one for the air source heat pumps retrofit.
Yes, that's right. Yeah, well done, Jen. Yeah, so it's Graham Hendra. If none of you have read any of Graham Hendra's LinkedIn articles and blogs, do make sure you follow him. He's got years and years and years of experience with air source heat pumps. Freedom Heat Pumps is his company. And he next week is going to be doing for us I think he said he was going to be walking around his house or something, but he was going to be talking about air source heat pumps in retrofit applications. And he's installed many heat pumps as they've evolved in his property, and he's got loads and loads of data, and really kind of down to earth guy, and what he doesn't know about air source heat pumps isn't really worth knowing. So do sign up for that one and check that one out. A final question I can see here from Laura: for the elements that we're going to be demolished, do we need to include them? Yes, this is one of the things we're trying to figure out, Laura. We've got at the top here, as Jen's got on her screen, we've got a line in here for demolition, line 19. That's major demolition, really. That's assuming you're knocking down huge parts of existing buildings. Where you've got smaller elements or kind of minor demolition, we're trying to figure out how you actually quantify that. You would include them down at the bottom, Jen, if you just scroll down to the bottom in the calculator. Pretty sure.
Oh, it's because I'm too far away. There we go.
So minor demolition. Oh no, okay. I'm sure there was something in there for. I'm sure there was something in maybe work to existing buildings. It would probably go in that bucket. we're still trying to figure that out, Laura. So when we do, we'll try and add an option in there. Some of this is still a bit fluffy. Some of this can be accurately worked out. So as you know, that's why we leave these kind of open. But as I say, if we can figure out a way of, like Rob was asking there about bathrooms, how the heck do we find out what needs to go in the FF and E box? Well, if we can work out a sensible way of figuring out what an ensuite has, you know, embodied carbon-wise in the RICS life cycle stages with a bath, a sink, you know, a shower and various other things in it, then we'll do that. But until that point, we're just going to have to scratch around and potentially guess some numbers and make others aware that those are estimates. But there's loads of work going on in the background, so you never know, and that may come sooner rather than later to allow us to populate those cells. We'll certainly let you know if we know. Okay, I think, folks, that is us. So a big thanks to Jen for showing us the calculator. As I say, do share your thoughts with us, and we look forward to hearing from you. So until next Wednesday, take care, and we'll look forward to seeing you at 10 o'clock next week. Bye-bye.